Good morning, Algebra 1 students, and welcome to Topic 6. This usually starts our second semester, so you're probably coming back from our winter break. Hopefully these first couple lessons are a really nice, mellow introduction to our unit, which is called Exponents and Exponential Functions. Technically, these first maybe one or two lessons are ones you've already had in middle school, but maybe your teacher skipped over them, maybe you don't remember them. So again, I'm hoping that they're a pretty nice, easy introduction to Topic 6. So without further ado, let's get started. We are on lesson 6.1, which are general exponent rules. We're actually spending 3 days on general exponent rules. This first lesson, though, are some very basic exponential rules. You might not even remember what an exponent is, so we're going to start with that. Our first rule that we're going to learn is about products of exponentials. We need to remember that the word product means multiply. And we're going to be multiplying exponentials with the same base. Now, what is a base? Well, in terms of exponents, there are usually a base and an exponent, where the base, and I'm going to do the base in yellow, is the large number in the problem. So in this first example, the 7 would be the base, or -4, or x. All of those would be bases. And exponents are, of course, the small number. And what does an exponent actually mean? Well, if you see 7 to the 4th power, it means you need to multiply 7 4 times, like so. And if you see 7 to the 5th power, you need to multiply 7 5 times. Now, if you use your calculator and you try to do 7 times 7 times 7, 9 times, you're going to get an absolutely massive number. Exponentials grow or get bigger really, really fast. So although you could find the actual answer on your calculator, that's not our goal for this lesson, for even these next couple lessons. What we're really just trying to do is there a more efficient way to write 7 to the 4th times 7 to the 5th? And the way that we do that is we write out 7 to the 4th times 7 to the 5th. So notice that I have 7 to the 4th right here, 7 to the 5th right here. What we need to realize is when you're multiplying all of this, you don't actually need your parentheses around the multiplication, right? There's, if you want, an invisible 1 out here, but we're not even going to worry about distributive property. One of our big properties of algebra is our associative property, which tells us within multiplication you can move or even drop the parentheses if there's only multiplication. So what this really is, and you don't need to write this, you can just think about it, is this is just 7 times 7 times 7 times 7 times 5 more 7s, like so. And so in fact, instead of thinking of it as 7 to the 4th times 7 to the 5th, notice that there are 9 7s multiplying together. And by the way, we call numbers that are separated by multiplication factors. You can also see them as products, but factors really mean the individual number. There are 9 individual numbers, there are 9 factors, which means instead of doing 7 to the 4th times 7 to the 5th, couldn't we just write this as 7 to the 9th power? I think that's a little bit more simplified than 7 to the 4th times 7 to the 5th. By the way, simplified is a kind of a weird math term. It's not something that's super easy to define. Usually simplified means the way to write an answer with the fewest number of letters, or numbers in this case. So because I had a 7, a 4, a 7, and a 5, and a dot in the middle, that was 5 different things going on. If I can just write that as 7 to the 9th, we say that's more simplified. So why don't you take a quick second and fill out the rest of this table, and then we'll see how you did and try to analyze or conclude the patterns that are in this table. Go ahead and pause me, fill this out. Ready, set, go. All right, hopefully we're back. I'm not going to write all of these out. You can just let me know if I did something wrong. I'm just going to go over our answers in the last 2 columns here. So negative 4 squared times negative 4 cubed. A couple things to note. First, when you write it out, there are going to be 5 factors, right? 1, 2, 3, 4, 5 of them. And second, when we write our final answer, it's actually going to be maybe not incorrect in this case, but incorrect many times if you just write negative 4 to the 5th power. I know what you mean, but it is very important that you actually group the negative 4 in parentheses, because otherwise what happens is, in terms of PEMDAS, what your calculator will do, and we will use a calculator eventually, is it will actually do 4 to the 5th power first, and then it will multiply a negative at the end. It sees the negative as being attached by multiplication, and we don't want that to happen. We want to tell the calculator that we're doing negative 4 times itself 5 times, not 4 times itself and then a negative at the end. So with negatives, you do have to put the parentheses. Now, if you have x to the first times x to the fifth, you'll find that you have 6 of those x's multiplying, and that's x to the sixth. You can put all of these in parentheses if you'd like. You can do 7 to the ninth, x to the sixth like that. There's nothing wrong with that. That's just extra, though, and you'll find that most, if not everyone, in mathematics further on won't put the parentheses. Okay, finishing off faster. There are 10 factors here, so we end up with c to the 10th. There are 7 factors, so this is a negative, so negative p to the 7th. Let's see, there are 5 and then 8 factors. I think that means that there are 13 factors here, so 4 to the 13th. There are 6 factors again, so x to the 6th. And there are 12 factors, y to the 12th. All right. Now, you'll notice that I skipped this middle section. I hope you did not, because I think that gives a good visual, and we're going to be doing that middle section many times over the next couple of days. But I skipped it, which means that there's probably going to be some way to quickly do that middle section, or a way to skip the middle section. And that becomes very important, because down below it asks you to find the simplified expression for 2 to the 24th times 2 to the 56th. Well, I certainly don't want to write out 24 2's and then 56 more of them. So what's the pattern? Do we, based on the multiplication sign, just multiply these two together? Well, I don't think so. If you look at these 6's, 6 times 6 is 36. We just said that it was 12. So I think, and hopefully you understand, that 2 to the 24th times 2 to the 56th is actually just 2 to the power of 24 plus 56 more. And when you do that math, you will get 2 to the 80th power. Yeah, nothing too bad. So when we have the same base, I think we can just add those exponents. If you wanted to see it done without numbers, when we had the same base of this 2 over here, 2 to the a times 2 to the b. And notice you didn't need parentheses around these. You could put these parentheses. They're optional. It's just going to be 2 to the a plus b power. So in words, when we have two exponentials multiplying with the same base, what do we do with the exponents? Well, you add the exponents, but keep the base the same. Easy enough. Now, I keep saying you have to have the same base, so just a little side note over here. If you had something like x squared times y cubed, you can't combine those together and say, oh, that's xy, let's see, 2 plus 3 to the 5th power. It doesn't work that way. If you have two different bases, you can't combine them together. So we're really just going to work in the case when you have the same base for now. Okay. Go ahead and take your calculator out. For your calculator, you're really going to need one like the Desmos calculator, where you can type in multiple things at the same time. Okay, so hopefully you have that Desmos calculator downloaded on your phone, or you have another calculator on the side where you can type everything in. I'd like you please to try negative 4 squared and negative 4 squared, one with parentheses, one without, and check those two answers. Now, before you check those two answers, let's think about what it means when you're doing negative 4 squared. I would hope that you'd agree with me that when you're squaring something, it means you take the base, which is negative 4, and you multiply it by itself twice. That's what a square means, right? It means there's two of the base multiplying. And a negative times a negative, I think, is a positive, isn't it? So the right answer here, I'm pretty sure, is 16. So this is, I'm just going to say by hand. I didn't use a calculator. Now, go ahead, use a calculator, and try negative 4 squared. And then also, please try in parentheses, negative 4 squared. And this part's going to be with a calculator. Unpause me once you're there. All right. Well, hopefully you see then the importance of including parentheses, because if you do negative 4 squared on a calculator, your calculator will do 4 squared first, which is 16, and then it will multiply the negative in at the end, right? PEMDAS here. Your calculator is doing the exponent first, and then the multiplication of the negative. And that's not what most people want when they do negative 4 squared. They want negative 4 squared to be equal to 16. So we want to make sure, if your goal is to square a negative number, that you don't put it in without parentheses and you do include parentheses. Okay, let's try one more set. This is just making sure you're comfortable with fractions. So you're going to try the following with a calculator. Okay, if you do it with a calculator, I want you to type it exactly as you see here, with parentheses, without parentheses, all that fun stuff. And then once you're done, come back and we'll talk about what answers you should have received on the calculator and what we're really doing by hand. Ready, set, go. All right. Well, when you do 1 divided by 2 squared on your calculator, what your calculator is going to do, and I'll zoom in here, is it's actually going to do 1 squared over 2. Okay? So depending on how you type this into your calculator, you might get 1 over 2. You might also get 1 over 4. Okay? But either way, similar to when we did the negatives up above, if you ever need to square a fraction, you really want to include parentheses around that fraction, because what we're really trying to tell the calculator to do is to do 1/2 times itself. And if you don't put the parentheses, some of your calculators might think they're doing 1 squared and then keeping 2 the same, but we would really want to multiply 1/2 times 1/2, multiplying straight across. We should get 1/4. Important to include those parentheses. And then same thing's going to happen over here. You might get negative 1/2, you might get negative 1/4. Either way though, 3 and 1 are not the way you want to type a squared fraction into your calculator. You want to type it in this way. You want your calculator to be doing negative 1/2 times negative 1/2, which is again positive 1/4, negative times a negative. All right, let's move on to the second part of today. The second part of today is what I call a power to a power. This is going to be where you have a base to a power on the inside, and then it could be a different power. You can see that down below. Another power on the outside of parentheses. And we're going to break down what this means really quickly. So we're going to work from the outside in. We're going to start with the fact that this whole, we're going to say base in quotes, is to the 3rd power, which means we need 3 of those 5 cubed. Sometimes you'll hear the 3rd power called a cube and a 2nd power called a square. Sorry, I should have mentioned that earlier. So 3rd power cubed means 3 of those 5 cubes. But then we also need to remember that 5 cubed means that it's 5 times 5 times 5. And so we're going to write that out. First we have our expanded expression based on the 3. Then we have the 5 cubed written out over here as 5 times 5 times 5. And you'll notice when you write all of those out, you'll get 555, 555, 555, which tells you that there are 9 factors. And so the simplified way to write 5 to the third or 5 cubed cubed is actually 5 to the 9th. So, using that, please go ahead and write out this entire table and see if you can simplify it all down. Once you're done, unpause and we'll go over those right answers. Ready, set, go. Alright, so hopefully everything went alright here. You should find, and I'll just demonstrate one of these and then we can check the rest, that negative 6 squared to the 4th means you have 4 of these negative 6 squareds, or negative 6 to the second power, right, like so. Right? And then each negative 6, and I'll keep these in parentheses, happens twice. There's 1, 2, 3, and 4. And when you write them out, you should see that there are now 8 factors. There are 8 negative 6's multiplying together, which means, and you do need parentheses, we can write this as negative 6 to the 8th. All right, for the rest of these, you'll find that there are 9 factors, so this is a to the 9th. 8 factors here, so this is z to the 8th. Okay, there are only 3 of these, so y cubed. There are actually 10 of these, and I know space gets kind of tight on these next couple, but there's 10 of these, so we write this as 3 to the 10th. And then this next one is a little bit weird because there's actually 2 of them happening. So we have 3 of these a cubes, so it's a cubed times a cubed times a cubed, and then there's this weird a squared just hanging out there at the end, right? Okay, and so that means we have a times a times a times a times a times a times a, and a squared, so a times a. And if you add all those up, you'll get 9 plus 2 more, which is 11. So this is a to the 11th. Okay, and we have 10 of these 25, so it becomes 25 to the 10th. All right, let's move into our Analyze section. This is going to first apply the pattern that we saw up above and then put that into words. So we're going to simplify 2 different exponential expressions here. We're going to simplify 2 to the 11th to the 72nd, and also 2 to the a to the b power. We really need to be comfortable looking at that pattern where you have an exponent parenthesis exponent, right? We see them both here, and that tells us, just as we saw up above, to simplify this down to only have 1 exponent instead of 2, we take the 11 and we multiply it times 72. Now, you can do this on your calculator, or you can maybe remember or learn your 11's trick. When you multiply by 11, you take the number you're multiplying, 72, you split it apart, add those digits together, 7 plus 2, which gives you 9. And so the simplified version of 2 to the 11th to the 72nd is 2 to the 792nd. That's a huge number. Imagine multiplying all that out, 2 times 2 times 2 times 2, 792 times. It is an enormous number. Well, what do we do, though, if our exponents aren't numbers? Well, our life is actually a little bit easier. We just take a and we have to multiply it by b, and you could even stop there. If you wanted, you could write this as 2ab. And that's that. So, in words, what are we doing when we have one exponential expression raised to another? Well, you multiply the exponents. So let's get a little practice in. I have 8 questions down at the bottom of this page. With these 8 questions, you can use your calculator to assist you if you need, but you should, of course, strive to try this without a calculator. Your goal is to write each problem so that there is a single base, so one big number, and a single power, just one exponent. Okay? And the trick here is you're going to have to decide, well, when do we add exponents and when do we multiply? So, see what you guys can do. Once you're done, you can unpause and check your answers with mine. Ready, set, go. All right. Part A, we have 2 of the same base with the exponents that are different. Doesn't matter if they're different or the same. And so we have 5 squared, which is 5 times 5, and 5 cubed, which is 5 times 5 times 5. So I think we are going to use the first page's rule where we add the exponents here, 2 plus 3, which just gives us 5 to the 5th power. That's in contrast to B, where you can see the parentheses. And when you have the parentheses, we need to remember that we multiply our powers, which gets us 10 to the 9th. Part C, same base. This is where we add the exponents. So this one should be negative 6 to the 1 plus 5, or negative 6 to the 6th power. Don't forget the parentheses around the negative 6. Part D, oh, I see parentheses, or in this case, these are actually brackets. And sometimes you'll see that so that you don't see parenthesis, parenthesis, like back to back. You'll see them different. You treat them just like parentheses. And so this is going to be negative 2 to the 3 times 3, or negative 2 to the 9th power. Moving on. M to the 6th times m to the 4th, m to the 10th, and c squared to the 6th power, c to the 12th. So then we get to part G, and that threw a lot of my students off because they saw this 9 squared, and then they saw this 3 halves. This is the fraction 3 halves power, and they're like, oh my gosh, what do I do? Well, it's really no different than f. To get f, you just had to do 2 times 6, which got you 12. And so we just need to take our exponents and multiply them together. It's going to be 9 times 2, or 2 to the power of 2 times 3 halves. Okay. You can do that on your calculator if you'd like, but it's not too bad to do without a calculator. 2 over 1, cross reduce. And so that gives us 9 to the 3 over 1 power, or just 9 to the 3rd power. Right? If you do 2 times 3 halves, you should get 3. And that's it. So let's try the last one. X to the 0.25 to the 8/5 power. Well, I think that's probably the same thing. We have to do 0.25 times 8/5. And I think this is usually easier if both of these are fractions. Hopefully we know 0.25 is the same thing as 1/4 times 8/5. Reduce. Divide both of these by 4. And then we multiply fractions straight across. 1 times 2 is 2. 1 times 5 is 5. And we're set, x to the 2/5. If you did it on your calculator, you might have also gotten a decimal of 0.4, which is totally fine. All right, on to the last page for today. The last page for today is really going to combine our two shortcuts. We're actually going to do the same problem in 2 different ways, but I'm going to ask you to just focus on these left 3 columns first. We'll do this right couple columns later on. Let's just focus on these. Okay? So I've given you, as before, one example. I want to clearly explain that example and then let you guys try the rest. So what's happening here is we have 2x squared that is being multiplied 3 times. So I've written 2x squared, 2x squared, 2x squared. Then, and this is the tricky part, I went ahead and broke apart each of these individual factors. Because although nothing is written, that means then that the 2 is attached to x squared with multiplication. Multiplication all the way through. And in fact, this 2 does not have an exponent of 2. The 2 is all by itself. And so what I did is I went through and grouped each of the 2's, because they're like terms, right next to each other. One of our fundamental properties of math tells us that we are allowed to rearrange multiplication in any order we would like. Right? Instead of doing 4 times 3, you could do 3 times 4. So instead of doing 2 times x squared times 2 times x squared and so on and so forth, I took the 2 and the 2 and the 2 and wrote them all first. Then I took the x squared, the x squared, and the x squareds and put them at the end. And now we can actually use the same rules that we used from the first page. We should know that when you do 2 times 2 times 2, that is 2 to the 3rd power. And when you do x squared times x squared times x squared, they're all the same base. And just like this previous page, when you have the same base, what do you do with the exponents? You add them. So this becomes 2 plus 2 more plus 2 more, which is x to the 6th power. Now, I wrote this as 8x to the 6th. It is totally okay to stop right here. Where does the 8 come from? Well, that just comes from multiplying all the 2's together. 2 times 2 is 4, times 1 more 2 gets you 8. All right, so now that you have the general idea, why don't you try the last 5 of these? And then based on how that goes, you can either check your answers with mine or you can move on to the shortcut. Ready, set, go. All right, I'll do the same thing here. So 3k to the 4th squared means we have 2 of these 3k to the 4ths. But then we can split this apart because we have a 3 that's out front and another 3 that's out front. Chasing down that extra multiplication. There we go. Good. Then we have a k to the 4th and another k to the 4th. So putting all of this together, we should end up with, let's see, a 3 times itself means there's 2 of those. And a k to the fourth times k to the fourth, same base, add the exponents as k to the eighth. You could also write that as 9k to the eighth. Okay, let's move a little quicker this time. We have y cubed h to the fourth times y cubed h to the fourth. I'm not even going to split them up. I think we can see this one. We have y cubed times y cubed more, which is y to the sixth, same base, add the exponents. And we have h to the fourth and h to the fourth, which is h to the eighth. All right, this next one I am going to split up just because I think it can be a little tricky here. We have 3c to the fifth g squared, and that is happening 3 times. So let's do our second one, c to the fifth g squared, and the last one. There we go. And then let's split all of these up. So I'll put all the 3's first. I'm just going to color coordinate. 3 times 3 times 3. That means there'll be a 3 cubed in the answer. And then c to the fifth, c to the fifth, c to the fifth. That means there will be a c to the 15th. And last but not least, g squared, g squared, g squared. 2 plus 2 plus 2 is going to be g to the sixth power. Okay. Let's see if we can do it a little faster without having to write out everything. This one's going to happen 4 times, 2x to the fourth, y to the fourth, 4 times though. So here's the second time, and the third time, and the fourth time. Space is getting a little tight. There we go. All right, well, how many 2's are multiplying? 1, 2, 3, 4. So this will have a 2 to the fourth. How many x's? X to the fourth, x to the fourth, x to the fourth, x to the fourth. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. And since y has the same power, y also has to be to the 16th. Okay. And last one. We have 3ab cubed, 3ab cubed, 3ab cubed. And so that's going to give us 3 to the third power, a to the 1, 2, there's only 3 a's there, so a to the third as well, and then b, 3, 6, 9. Great. Now, this would be a little bit tedious if you had to write out the problem this way every time. And full disclosure, you can write these out like this every time. But we are really looking for shortcuts here, and this is again going to kind of bring together everything we've done so far. We saw when we wrote it out, we had to add the exponents. But it should be a bit of a giveaway that we have an exponent parentheses exponent. Because when we saw on the previous page with that parentheses, exponent, parentheses, we were able to just multiply. So what we're going to focus on for this last shortcut are the answers that are over here now and how we can get those same answers, using a shortcut. So let's take a look. 2x squared to the third power. What I see some people try and do is they just say, oh, this 3 just multiplies here. 3 times 2 is 6. We're done. But I didn't get 2x to the sixth, nor does this 2 go on both of these. So what's going to really kind of break this case wide open for you is realizing or remembering that the 2 is attached to x squared with multiplication. And so we can and should write those separate from each other. The 2 stays with the x squared, but there's only a single 2 right here. And so although nothing is written in the exponent spot, we can always put an invisible 1 if there is only one of a number or a variable. And so you'll notice when I split it, I put a 1 here. Then we're going to go through and use our property from the second page. Parenthesis, exponent, parenthesis means we multiply. And in fact, we are able to take this 3 and distribute to both of these on the inside. When you clean this up, you'll get 2 to the 1 times 3, which is 2 cubed, and x to the 2 times 3, which is x to the 6th. Okay, that does match our answer that we got before. So let's try another one. This 2 is going to distribute, but the question is, where does it distribute to the 3
Well, we need to remember that the 3 does not have the fourth power that's attached to k. It's attached by multiplication. There's no power on there, so we put the invisible 1 in. Now we can distribute the 2. So we get 3 to the 1 times 2 and k to the 4 times 2, which leads us to match our answer from over here. We end up with 3 squared k to the 8th. This next one's pretty easy because there's no number out front. We're just going to go ahead and distribute the 2 into both of these, right? So we get y to the 3 times 2 times h to the 4 times 2. So y to the 6th, h to the 8th. Moving on through. Here's one we actually have to do on our own. So we're going to split this apart. We have a 3, a c, and a g. The g has a 2, the c has a 5. What does the 3 have? An invisible 1. And we're going to take the 3 that's on the outside and distribute. So this becomes 3, trying to color code this, 3 to the 1st, leave some space, times c to the 5th, times g squared, and we are distributing the 3 that's on the outside every time. This gives us 3 to the 3rd, c to the 15th, and g to the 6th, which does match. All right, can we see if we can just skip right to the end now, or at least do the middle step? This 4 is going to distribute to all 3 of these. There's that invisible 1 there. So this should, I think, give us 2 to the 4th. 4 times 4 is 16. 4 times 4 is 16. And there we go. Last one. Let's put those invisible 1s. Where are the invisible 1s? Well, 3 certainly has one. Oh, I think A has one as well. A and B don't both have the cube, just B does. So when we distribute here, I think for our final answer, we'll get 3 to the 3rd, A to the 3rd, B to the 9th. So what's going on here? Well, the shortcut has to do with distributive property. Okay, so we can multiply the outside exponent to all exponents in the parentheses. Now, I've mentioned this before in the past, and this is really going to be big this semester. Distributing exponents, distributing anything, is a shortcut. And with exponents, this shortcut only works when you have multiplication or division. We're going to do a lot more about this later on. But yeah, it's only going to work with multiplication or division. So let's go ahead and try the shortcut from the table on each of these down below, and then we'll finish off today with a quick conclusion. All right, part A. And you, of course, should work on ahead without me, totally fine. But part A, 3x squared. Well, we know we're allowed to distribute the square, but in order to do that, we need to know what the exponent is on each of these values. The 3 has an invisible 1, the x has an invisible 1, and then we can distribute the 2 to both. So that gives us 3 squared x squared. Now part B is something we haven't talked about yet. However, part B is a fraction that's created by using division. And what you'll find, at least in algebra, is whatever you're allowed to do with multiplication in algebra, you're also allowed to do it with division. And so we're going to rewrite this as 3 to the 1st over x to the 1st squared. And we are allowed to take the square and distribute it to both parts of the fraction. 3 squared, 3 squared divided by x squared. But then disaster strikes. 3 plus x squared. I mentioned up above that this shortcut only works with multiplication or division. And it turns out that we are not allowed to distribute and say that this is 3 squared plus x squared. Not only have we not talked about it, that is actually wrong. It is not the correct answer. You cannot do that. That is a no-no. There is addition. And looking at that, let's go ahead and identify the others we can't do either. Oh, D. This one is subtraction. We cannot distribute with subtraction. It's not doable. We don't know how to simplify this yet, but we cannot use that shortcut. Are there any others? Oh, I. I is adding right here. Okay, so we can also, and I should cross them out like this, we can also not distribute with addition. However, as long as there's multiplication or division, we should be fine. So let's look at part E. That's a fraction to the third power, but great. Fractions are easy. Fractions are just division. 5 to the first over 2 to the first cubed. Distribute the 3. 5 cubed over 2 cubed. F, well, this is just multiplication. All right, so we have a 1 and a 1. We distribute the 2. This gives us negative 2, we do need the parentheses, squared, times 2 squared. Now, I have had students in the past say, oh, wait, can't you just multiply the inside to get negative 4 squared? Yes, you're right. That does give you the exact same answer. But we're focusing on the shortcut, which is why I went this way. All right, let's look at our last two. I think we should be able to take that 4 and distribute x to the 12th, y to the 8th. And last but not least, 1.5. Invisible 1. We need to multiply 1.5 times each of those. A to the 1.5 over b, let's see, 1.5 times 3. I think that's 4.5. It's supposed to be a 5. And there we go. That's it. We don't know what 1.5 powers do yet. We'll learn about those later on. But either way, we should at least now have enough to understand how to list our rules that we learned today. If you have two bases with two exponents and the bases are the same, then we combine them to a single base and do what with the exponents? Oh, that's right, we add them, m plus n. So when you multiply two terms with the same base, you add the exponents. When you have an exponent parenthesis exponent, we need to go through and do m times n. So when you have an exponent on the outside of parentheses, you multiply. Last but not least, if you have a situation where there's more than one factor inside the parentheses, we don't want to forget to add in the invisible 1 to a. Once we've done that, then we can distribute, or you could say multiply here, multiply the exponents. So n times 1 will be n times m will be m times n, or the other way around is fine too. All right, so hopefully you're feeling pretty okay about this. We don't have to do any crazy hard problems this year. You'll do more of those in Algebra 2, but we absolutely need to know that when you have the same base and you're multiplying, you add the exponents, and you have an exponent on the outside of the parentheses and the inside, you multiply. So thanks for hanging out with me. Don't forget to do your independent practice, your homework tonight, and I'm excited to have you back next class for lesson 6.2.